So my name again is Celestine Nemeka. I'm your chemistry teacher. So we are going to be dealing with alkanols. So by the end of this lesson, you should be able to, number one, define, sorry, let me move this. Just a moment. Okay, so you should be able to define an alkanol and identify its general formula and functional group. Secondly, you should be able to classify alkanols as primary, secondary, or tertiary. Prepare alkanol. You are going to describe two industrial methods of preparing alkanol, and you should be able to prepare using at least one of these methods. Then state the key chemical reactions of alkanols. Okay. Then apply. By application now, you relate the properties of alkanols to everyday uses. Okay. So we are in the 21st century, so we stick to 21st century pedagogy when it comes to teaching. So I want you to write this down. Write this down. Or if you're using a phone, just screenshot. I'll be giving you just 60 seconds to do that real fast. If you're using a phone, screenshot. If you're using a laptop or a desktop, quickly write it down. Because at the end of the class, these are the things that I expect that you should achieve. And if you've not achieved any of them, please let me know. Please ask your questions. Is that clear? Good. That said, in a few more seconds, we'll proceed. I believe you've taken your screenshot, and I also believe you have you are copying it and you are done copying it now. So let's fire on. What are alkanols? We are starting from the basics. What exactly are alkanols? Now, I want somebody to read this. Ekene Chimamanda, can you please read what's on the screen?
What are alkanols? Alkanols are homologous series of organic compounds containing the hydroxyl OH- functional group attached to a saturated carbon chain.
Beautiful. Beautiful. You can mute yourself now. Alkanols are a homologous series of organic compounds containing the hydroxyl functional group attached to a saturated carbon chain. Are we together? So let's look at the terms there to be sure you understand each of those terms. First, a homologous series. Homologous series is a family of organic compounds that have similar structures and successive members differ by a CH2 group. All right? They have similar structure, they have related chemical behaviors, and members differ by a CH2 group. Is that clear? Now, we have, okay, just a minute, please. Just a minute. Okay, sorry there. I was just trying to sort out a little problem there. All right, so we've talked about what homologous series are. We know organic compounds are compounds of carbon, often with oxygen and hydrogen, okay? Then containing hydroxyl group. hydroxyl group. That is the functional group, OH. So if you see an organic compound that has OH, let me show you what I mean now. If you see an organic compound, okay, that has OH, okay, it is bonded to hydrogen, and whatever it is bonded to, once it ends like this with OH, then it is an alkanol. Is that clear? Please take note. Once it ends like this, CH2OH, then it is an alkanol. I hope that is clear. I hope that is clear.
Yes.
Good. So just a moment again. Just a moment, please. I'm trying to sort something out. Okay, so sorry, I had to rectify a problem with the other class. I believe everybody is still with me here. So let me clear this. Sorry about that. So we say the OH is the functional group of alkanols. Now, there's what we call general formula. If you have done homologous series, every family of organic compounds have their general formula. Are we together? Every family have their general formula. And the general formula for alkanols is CnH2n plus 1 OH. Please write that down. Very, very important. Very, very crucial. CnH2n plus 1 OH. And I need you to be taking note of all these details I'm giving you, because very soon, in a short while, you will be answering questions based on these. So now the functional group is OH. And a typical example, the most common example is ethanol with the formula C2H5OH. So we are assuming, we are not, in this case, the N, which is the number of carbon, N is the number of carbon, the N here is 2. Okay, and if you put 2 in front of carbon and you put 2 times 2, which is 4 plus 1, that will give us 5. That's why we have H5. All right, then OH, which is the functional group. Now, this is the structure, this is the formula of ethanol once more. I want somebody to write us the structure of ethanol. Is there anybody here who can write us the structure of ethanol? Now, look down if you're using your mobile phone, keep it landscape, that's horizontal. At the bottom corner, bottom left corner, you're going to see a pencil in a circle. So pick it up, okay, and use it to write me the structure of ethanol. The first person to start, I'll see your name, then you are the one that will go on. Yes. Who is going to write me the structure of ethanol?
I can write. Okay. I've seen it.
Okay. Okay. Okafor Kenechukwu, you are using a laptop.
Yeah.
Okay. Are you using your mouse to write it?
No, I'm using
the screen.
As in.
Okay, go on. Just go on. Just go on. Yeah. Everybody pay attention. If he's correct, you are going to give him tada. If he's not correct, you let me know. If it's not correct, you unmute your microphone and contest. Okay. Okay. We are inching close. We are inching close. Everybody go to your tada and wait. It's not when I say give the tada, you start looking for it. Go there and wait. As soon as I say, okay. If you agree with him, give him tada. If you do not agree, unmute your microphone and contest. Okay. Okay. Oh, very good. So, Okafor Kenechukwu, that's for you. Very good. They all agree with you. That is the structure of ethanol. That is correct. That is the structure of ethanol. Are we together? So everybody take note of that. Take note of that. Then let's proceed. Now, I need everybody to do this in their notebooks. You're going to do it in your notebook. Then what is in your notebook? I think how many of you are here? What is in your notebook? You're going to replicate on my screen. I'm going to call, okay, this time around, I'm going to call Ugoma. Ugoma, I want you to answer this. Meanwhile, every other person do theirs on their, that's in their notebooks. Every other person do yours in your notebook. Ugoma, I need you to do it on the screen. Ugoma, are you using a phone or a laptop? Ugoma, are you still with us? Ugoma. Okay, Ugoma is not with us. Ekene Chimamanda, please. Okay, Ekene, hold on. Ekene has answered a question today. Emmanuel Famiroju, I want to be sure you are here too. Unmute yourself first. Very good, Emmanuel. So, Emmanuel, I want you to pick the pencil from the bottom left corner and write. Are you using a phone or a laptop?
Phone.
Phone. Okay, very good. So, pick the pen from the bottom left corner. Then write me the structure of the alkanol that has 4 carbon atoms. Sorry, not structure, just formula. Formula, not structure. Okay? Just formula. Njoku Ugoma, what happened? Ugoma, why did you bolt on us? Emmanuel, we are waiting for you. Okay. Go on, go on. Don't worry, very soon you will get stylus. Okay? Every one of you should get stylus. Later on after the class, I'm going to tell you, get stylus. It's not expensive, 2005. Okay? It's just 2005. Yeah, what am I seeing there? C4H9OH. That's correct. Oh, come on, please mute yourselves. Mute yourselves, everybody. Quick. Immediately, immediately. Yeah, everybody, tada for Emmanuel. Everybody, tada for Emmanuel. Quickly. Emmanuel, that's for you. That's for you. Very good. Very good. You got that right. Okay? You got that right. So let's proceed from here now. I didn't see some people start out. I didn't see some people start out. Okay, so let's clear this. Now, homologous series and nomenclature. Homologous series and nomenclature. Ekene?
Yes, sir.
Yeah, please read this again.
Homologous series and nomenclature. Alkanols are named by replacing the E ending of the parent alkaline with
Alkane.
OL. Each
Alkane.
member
Parent
differs
alkane.
the next of the parent alkane
That's right.
with OL. Each member differs from the next by a CH2 unit.
Very good. Very good. Alkanols are named by replacing the E ending. Okay? So if you get to the alkane, the E ending is this. This is the E ending here. This E here. Okay? You replace the E ending with OL. If you replace the E ending with OL, it becomes the corresponding alkanol. So we have methane, and the corresponding alkanol is methanol. Is that clear? So good. Let's proceed. Famiroju, can you name the first 5 alkanols as seen on the board?
Methanol,
Okay.
ethanol,
Uh-huh.
propanol,
Uh-huh.
butanol, and pentanol.
And pentanol. Very good. Very good. These are the first 5 alkanols that are known. After pentanol, we have hexanol, then we have heptanol, then we have octanol, then nonanol, and decanol, as the case may be, like that, okay? With the corresponding number of carbon atoms. Now, pay attention to their formulas. Pay attention to their formulas. But there is something about propanol, butanol, and pentanol. For those that have done naming, there is something about pentanol, propanol, and butanol. You don't just say propanol, okay? You don't just say propanol. Now, look at that. What was his name again? What are we calling now? Okafor. Kenechukwu. Kenechukwu,
Yes, sir.
can you read what you can see there? The strip by the right.
Okay. Remember, locants show the minus OH position.
Okay.
Example, butan 2-ol.
Hmm.
Numbering gives the minus OH group the lowest possible number.
Okay.
The minus OH carbon is C1 when naming from an end.
Very good. Very good. I'm going to explain what these 3 mean, but before I do that, that is not minus OH, okay? You don't have to mention the minus. That minus there is actually showing you that it is not a compound of its own. It is actually attached to another atom, okay? It is just part of a compound. So that thing you are calling minus OH is actually a bond. It's actually a covalent bond, showing that that oxygen is attached to another atom, in this case, carbon. So what are locants? Locants is just like if you look at butan 2-ol, that 2 there is telling us the location of the OH. Okay? That's the location of the OH, butan 2-ol. Okay? Then numbering gives the OH group the lowest possible number. The OH carbon is C1 when naming from an end. That is rule for naming. That's the rule for if you are applying the the organic nomenclature to this. Remember, the rule says that you are going to start counting your carbon atoms on the chain from the end that is closest to the functional group. Okay, so if the functional group is at a terminal carbon, is on a terminal carbon, then that is where your number 1 is. That carbon that is bearing the OH becomes your number 1. But if the OH is not on the terminal carbon, is somewhere at the center, what you now do is to check. If you count from this side, if you count from the other side, which will give you the shortest position for that carbon bearing the OH. The shortest one is the one you will use. I hope you understand that. The shortest one is the one you are going to use. So real quick, we are going to classify alkanols. Okay? We are going to classify alkanols into primary, secondary, and tertiary. And I want you to pay close attention. I want you to pay close attention because when WIAC want to ask questions, their question is usually hinged. It's usually hinged to these concepts. Okay? So primary alkanol. A primary alkanol, in fact, let me put it this way. To identify the type of alkanol or the class of alkanol, you are supposed to look for the carbon bearing the OH group. So For example, if this is carbon and this is OH, okay? And this carbon is bonded to some other things. Now, this carbon is what will determine if the alkanol is primary, secondary, or tertiary. Okay, this is our alpha carbon. Okay, now, if the carbon is bonded to only one other carbon or no carbon at all, if it is bonded to only one carbon directly, I'm not talking about bonded to a chain of carbon atoms. No, the number of carbon atoms it is directly bonded to will tell you whether it's primary, secondary, or tertiary. Now, in this case, if it is bonded to only one, like we can see here, and the remaining bonds are to hydrogen, like this, then this is a primary alkanol. Remember, it doesn't even matter how many carbons you have on the chain. The chain can be from here to Sokoto. The only thing that matters to us is how many carbons are bonded to this particular carbon. In fact, let me use a special color for it because it is our alpha carbon. This is our alpha carbon. This is the chief. Are we together now? So this one, because it is bonded to only one carbon, it is a primary alkanol. If it is bonded to no other carbon atom, that means it is just bonded to only hydrogens, it is also a primary alkanol. So in this case, it is this is ethanol, and ethanol is a primary alkanol. Are we together? Ethanol is a primary alkanol.
Go to the main this and send it to SS.
Yeah, sorry about that. So this is for primary alkanol. Now for secondary alkanol, again, we are going to show our alpha carbon. Remember, our alpha carbon is the one bearing the OH. So this alpha carbon is bonded to OH. So let's put our OH there. Now, when you are showing your OH, be very careful to ensure that your OH, the bond, is directed to O, not to H. Do you understand? The bond should be directed to O, not to H. Then this is bonded to another carbon here. Okay, this carbon has its hydrogens. Okay, this one, it is bonded to one hydrogen. Then it is bonded to another carbon here, as you can see. As you can see. Now, this is propan-2-ol. Propan-2-ol. Now, it is propan-2-ol because the hydroxyl group is on carbon 2. That is for the nomenclature. Now, when we come to the classification of alkanols, when we now come to the classification, you see that our alpha carbon, remember our chief now, is at the center. And it is bonded to two different carbon atoms. Because it is bonded to two carbon atoms, it is a secondary alkanol. And we usually denote it with 2 degree, as you can see here. 2 degree. That will also remind you that it is bonded to two carbon atoms. Are we together? So I'm going to pause here, then ask you, if you have any confusion, please ask now before I go to tertiary alkanols. Feel free to unmute yourself and ask your question before I move to tertiary alkanols. Any question?
What do you mean by two other carbons?
Oh, very good. Very good. Can you see the carbon, the blue carbon there? Unmute yourself.
Yes.
Good. How many carbons are directly bonded to it?
2 carbons.
That is what I mean.
Oh, okay.
Do you understand? Now, it doesn't matter if this is carbon. If this is carbon and this is carbon and the carbon chain continues, it doesn't matter. What matters to us is that this one, this particular one at the center is bonded to this and is bonded to this. That's all. That's the 2 carbon atoms I'm referring to. Okay? So let me remove these extras that I added by way of illustration. I hope you understand it now.
Yes.
So any other question? Any other question? Okay, no other question. So, since since the classification is based on the number of carbon atoms, who can now tell me what it will be for tertiary alkanols? Who can draw for tertiary alkanols? What will the structure look like for tertiary alkanols? Okay, to save time, I'm going to draw it myself. So first, I'm going to start with my alpha, my main carbon, isn't it? And this carbon is the one bearing the functional group. So let me put the functional group there. It's bearing the functional group OH. Okay? This is bearing the functional group OH. Then when we say it is bonded to 3 other carbon atoms, that means it is at a junction. So let me show you. This is carbon. So let's call this CH3. Then this is another carbon. I'm writing it as CH3 so that it won't look too cluttered. Okay, so this is another C. So here now, let me show the hydrogens so that it won't confuse anybody. Let's just show everything. Then here again is bonded to another carbon. Can everybody see that this particular blue carbon, which is our main carbon, is actually bonded to 3 different carbons? Because it is bonded to 3 other carbons directly, remember, I am saying directly. Please take notes. I didn't say you should count the number of carbons in the alkanol. The only carbons you are counting are the ones that are directly linked to the alpha carbon. So, Okafo Kenechukwu, your hand is raised. Go on, unmute yourself and ask your question.
If they tell us to write this structure like this, can we write that CH3 without splitting?
No. Actually, if the exam question says write the structure means you must show every bond. Every bond. In fact, because of that, let me remove that CH3 I wrote. If the question says write the structure, you have no reason to write CH3 anywhere. You have to show every bond. Any bond that is missing is a loss for you. That's a loss of score for you. I was doing it so that it won't clutter the whole space, but I'm sure you understand what what I drew there, right?
Yes.
Good.
Yes.
So does any other person have a question? Let me repeat this thing I said before. What you are counting is not the number of carbon atoms on the chain. What you are counting is the number of carbon atoms that are directly linked to that carbon that is bearing the functional group. So anytime you are to classify an alkanol as primary, secondary, or tertiary, go straight to that carbon where the OH is. That carbon where the OH is, mark that carbon. Now, how many carbon atoms are directly bonded to that particular carbon will tell you whether it is primary, secondary, or tertiary. So I repeat, if it is one carbon directly bonded, then it is primary. If it is two carbons directly bonded to that alpha carbon, then it is secondary. Then if it is three carbons, then it is tertiary, as you can see here. So 2-methyl-propan-2-ol, you can see how it is written. And another thing I need you to take note of, I'm going to clean my board a little bit so that you pay attention to this thing. You see how this 2-methyl-propan-2-ol is written? That is how they write it in exam. So you see this one. Hold on, just a minute there. You see this. This is how they write it in exam. They are not going to show you the way I'm spreading it here. They are not going to show you the way I'm spreading it here. So how do you now know if they write it this way? Look at this one now. If they write it this way, how do you now know whether it is primary, secondary, or tertiary? Look at this one. How do you now know? Now, this is how you will know. Pay attention. Follow the OH. Follow the what? OH. All right? Now, on this one, you will see that the OH is at the terminal. And it means that it is bonded to the carbon before it. Every OH you see in the structure is bonded to the carbon before it. So what I mean, therefore, is that this OH is bonded to this carbon. Can you see that, everybody? I believe you can see what I'm showing you. That OH is bonded to the carbon before it. And the reason why they put the OH in brackets is so that you will not confuse that functional group for something else, thinking that the carbon bonded to hydrogen, the hydrogen to oxygen, the oxygen to hydrogen, the hydrogen to carbon. Okay, so they put the OH in bracket to show you that this is the functional group. They are together, and it is bonded to the carbon before it. Then for this last one here, you see also the OH is here. It is obviously bonded to this carbon before it. So if they give you this condensed structure instead of, or maybe expanded formula, instead of the structure, just use the OH, bond it to the carbon before it. Now, where it gets confusing, is with this one. Let me show you again, because this is very crucial. Look at the CH3s. They have 3 CH3s. Look at them. They wrote CH3, then they wrote 3 outside. This simply tells you that there are 3 CH3s bonded to this carbon. Of course, they can't put them after, okay? Because it is this one now that they are showing that is bonded to this. So they usually write it before. Okay, so what I'm saying here right now is that when you see this CH3 like this particular CH3 times 3, it means that there are 3 CH3s directly bonded to this. That means there are 3 carbons bonded to that particular carbon. That carbon you are seeing there that the arrow is pointing to is the carbon we are looking for, is the chief carbon that determines whether it is primary, secondary, or tertiary. I hope this is clear. Please, if it is confusing again, I need you to open your mic and ask your question, or raise up your hand first. If I call on you, you ask your question. I'm going to wait for another 30 seconds. Okay. Okay, since nobody is raising their hands, it means that we all understood the explanation here. Okay, so I'm going to clear this real quick. So we'll move to the next thing. Now, everybody look at this. Everybody look at this now. I want you to go to the chart. Go to the chart and answer this question. I'm looking at the chart right now. Go to the chart and answer this question. You are going to write whether it is primary, secondary, or tertiary, and you are going to write your reason. Everybody to the chart, everybody. If you tap on your screen, you are going to see charts. If you don't see charts, go to the 3 dots or more. If you tap on more, you're going to see charts there. Then open charts, then tap on the query and start entering. Tap on the space there and start entering. Classify CH3, CH2, CH bracket open, OH bracket close, CH3 as a primary, secondary, or tertiary alcohol and explain your reasoning. You have 60 more seconds. You have 60 more seconds. Let's go. Let's see the first person to appear. Tick, tock, tick, tock. Okay. I'm seeing the first one. I'm seeing the first one. Okay. Okay. Let's wait for others. Let's wait for others. Okay. I've gotten a response from Ekene Chimamanda. And good, I've also gotten a response from Onkakalu Samuel. Okay. 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 There are some people that are in class that are not responding. I want to get everybody's response. Everybody is participating in this. Everybody. I will spare the SS2 students that just joined us. SS2 students, this is also chemistry. Everybody is going to learn from it today. So SS3, yes, you have not answered your own. I'm waiting for your own response.
Yeah, that's the problem. My chat doesn't work.
Why is it not working?
I don't know, but I've answered it. I can say my answer.
Okay, say your answer. Let us hear it.
It's secondary alcohol.
Okay, you think it is a secondary alcohol. Why?
Because it's attached to 2 other carbon atoms.
Okay.
One.
Okay.
That's it.
Okay. Ekene Chimamanda, do you agree with her? Ekene Chimamanda, unmute yourself. Do you agree with her?
Yes, sir.
Okay, you agree with her. I want to hear you. I want to hear you.
Yes, sir.
Okay, so what you are saying in essence is that you are repenting from your initial assertion.
I agree with that.
Okay, okay, okay. So yes, this is a
Yes, sir.
thank you very much for all your contributions. Yes, this is a secondary alkanol. And the reason why we say it's a secondary alkanol is because it is bonded to remember I kept emphasizing, it is directly bonded to 2 other carbon atoms. Now, if you look at this structure, let me move this somewhere. If you look at this structure, this here is the carbon of interest, isn't it? Because we said that this OH is directly bonded to it. So if you look at this structure, you see that this carbon is bonded to this carbon, and it is also bonded to the next carbon. The OH might be up and the H down, or the H up and the OH down. I hope that is clear. So that structure there is actually like this. Let me draw it for the sake of those who will want it expanded. I do not want anybody getting confused. So this is CH3. That's our CH3 here now. So I'm drawing the CH2. This is the CH2 here now. Okay. Oh, sorry. Yeah, Victory, why are you still here?
I've been trying to join the other people, but it's not allowing.
What do you mean it's not allowing? What's the problem?
And if I click on it, it won't allow me to enter.
Wow, I noticed that. I don't know. I don't know what exactly is the reason. I don't know what exactly is the reason. Everybody's own is showing move to, but your own is not showing anything. So this is what you do. Log out and log back in. Do it quickly, okay? Log out and log back in. All right?
Okay, sir.
Good.
Okay, sir.
Okay, sorry right there. I went out briefly to assist a student that needed help. So let's go back. So I was writing the structure of that compound. Let me do it again. Sorry. Let me do it again now. So we have CH3 like this. Okay. Then that's our CH2. Then CHOH. Can you see that? Then CH3 like this. So this is the expanded structure. Now, to avoid confusion, this is the first CH3, this is the CH2, this is the CHOH, then this here is the last CH3. I believe this is very, very clear to everyone. All right? So who can name this? Who can name this organic compound? Anybody? Okay, the name is butan-2-ol. You may want to draw the structure and write the name. It is butan-2-ol. Maybe one of these days we'll go back to naming, reconsolidate that naming very, very well because it's very, very important. Okay, we'll go back and look at that naming again, then forge ahead. So, where are we now? We have answered this question. Any question on this? If you have any issue with this, please let me know before we proceed. I don't want to leave anybody behind. I do not want to leave anybody behind. Just unmute yourself and speak. Okay. No question? Onwukakalu Samuel, looks like your microphone is coming off and on. Do you want to ask a question? Oh. Uh-oh. Chinyere, do you have a question? Though you are in SS2. Chinyere, can you hear me?
Yes, sir.
Okay. Do you have a question?
No.
Okay. So I want to believe everybody is with me now. So let's fire on. I will clear this and we'll move on. Now, physical properties of alkanols. We have talked about the what do we call it? The classification of alkanols into primary, secondary, and tertiary. Let's go to the physical properties of alkanols. Number 1. Who can read this for us? Okafor, your network is very sharp. It's very, very sharp. I like your network. Oh yeah, read.
Hydrogen bonding.
Okay.
The OH group forms hydrogen bonds between molecules, giving alkanols higher boiling point than alkanes of similar mass.
Good. It means that alkanols have a higher boiling point, far higher boiling point as compared to the corresponding alkanes. Okay? For example, if you look at ethanol and ethane, the boiling point of ethane is almost is far below 0 degrees centigrade. But the boiling point of ethanol is in the neighborhood of 75 degrees centigrade. You see that the gap is not here. The gap is very loud. Okay? But what is hydrogen bonding? We must recall. Hydrogen bonding is the intermolecular force of attraction between hydrogen and highly electronegative elements such as oxygen, fluorine, and nitrogen. Okay? In this case, because there is OH group, let me show you now, just for illustration. I need us to understand this. Because there is OH group, so let me write it as ROH. Okay? And there is another, let's say ROH. Okay? There will be an interaction between this molecule and this molecule. Now, remember, hydrogen bonding are represented with broken lines. They are represented with broken lines. That's dots, dotted lines. Okay? If you do this, then you are referring to covalent bond. Are we together? If you do this, then you are referring to covalent bond and not hydrogen bond. So hydrogen bonds are, we use dotted lines for hydrogen bonds. I hope that is clear. Now, that said, this bond is so strong that it makes the boiling point of alkanols to be far higher than those of the corresponding alkanes. Are we together? Good. So let's clear this. Okafor, stay with me. Stay with me. Stay with me. I want us to go to the next one. Read.
Boiling point trend. Boiling point rises steadily as chain length, and so molecular mass increases along the series.
Very good. What that is quite obvious. As the molecule gets bigger, as the number of carbon increase, the boiling points also increase. Are we together? As the number of carbon increase, the boiling points increase. And this is typical, even for alkanes, it's the same thing. As the number of carbons increase, as the molecule gets bigger, the boiling point also increases. So real quick, number 3, Okafor, stay with me.
Solubility in water. Lower alkanols, methanol to propanol, mix freely with water due to hydrogen bonding.
Good.
Solubility falls as the carbon chain gets longer.
Very good. Very good. So again, alkanols dissolve readily in water. Remember, most organic compounds do not dissolve in water. Okay? They do not dissolve in water because water is a polar solvent, while most of these organic compounds are non-polar. But because of hydrogen bonding interaction between water molecule and the OH in alkanols generally dissolve in water. But actually, the high solubility is seen in methanol all the way, methanol, ethanol, and propanol. But as we enter butanol, pentanol, hexanol, the solubility keeps dropping. Are we together? The solubility reduces. So the smaller alkanols tend to be more soluble in water. So give me the last one.
Volatility. Lower members are volatile, colorless liquids with a characteristic smell. Higher members become oily and less volatile.
Very good. That also is typical. Thank you very much. Thank you. That also is typical, given that the higher the chain length, the higher the boiling point. So we should expect that about its volatility also. The higher the chain length, the lower the volatility. Okay? Because the volatility, you know what volatility is? Volatile. A volatile liquid is one that evaporates on its own at room temperature. Okay, it evaporates easily at room temperature. So a very volatile liquid is the one that evaporates very, very fast. Very, very fast. It evaporates faster than others. So in order to be sure that you understand what I just explained now, I want somebody to answer this question. Petrol and water, which one is more volatile? Petrol or petrol, if you prefer, and water, which one is more volatile? Unmute yourself and speak.
Petrol.
Petrol is more volatile.
Petrol.
Petrol is more volatile. Very good. I agree. Petrol is more volatile. Okay? Good. So just to be sure you understand what I mean by volatility. Okay. Let's look at industrial preparation. In this industrial preparation, we are going to be looking at two different methods of preparing ethanol industrially. One is by fermentation. The other one is by hydration. So let's start with fermentation. Sugars are broken down by yeast enzymes. The enzyme in yeast that is responsible for this fermentation process is called zymase or zymase actually, in the absence of air. Fermentation, you may want to write this down. Fermentation is the anaerobic decomposition. Fermentation is anaerobic decomposition of sugars. Anaerobic decomposition of sugars to produce ethanol and carbon dioxide. Anaerobic decomposition of sugars to produce ethanol and carbon dioxide. Are you with me there?
Yes.
Good. Now, if that is the case, glucose is a sugar, is a monosaccharide, is a type of sugar. So that formula there, that equation there, or hold on, that formula there, C6H12O6, is the formula of glucose. So the equation represents the fermentation of glucose to produce ethanol, and the byproduct is what? Carbon dioxide, carbon dioxide. So C2H5OH and CO2 are the products of fermentation. Now, pay attention to the conditions. A warm temperature between 30 to 35 degrees centigrade. Okay? Then the presence of yeast. Remember, the yeast is not the enzyme. Yeast contains the enzyme. Okay? Yeast contains the enzyme. And what's the name of the enzyme? Real quick, somebody. Okay, for not you. Real quick, what's the name of the enzyme? Okay? My students are watching African Magic. My students are watching. So that is what you are doing. Watching African Magic. I asked a question. I need an answer. What is the name of the enzyme in yeast that is responsible for fermentation? Unmute yourself quickly and answer.
Zymase.
Zymase, very good. Zymase, very good. So the name of the enzyme is zymase. Remember, I repeat, the enzyme is not yeast. The enzyme is present in yeast. Now, absence of oxygen, that is why we say anaerobic. Anaerobic, okay? Then fermentation stops at about 18% concentration. Now, everybody listen to this. Everybody listen attentively to this. When you collect yeast, Or hold on, if you collect sugar, let's start from the sugar, you put in water. Let's say you have a PET bottle like this, okay? And you put water halfway, and you put sugar in it, maybe 1 spoonful of sugar in it, and you dissolve the sugar. Then you add a pinch of yeast, active yeast. It's not expired yeast, active yeast. You put inside, then you cover it. You cover it, then shake, then allow to sit in a warm place. Allow to stay in a warm place. Fermentation will start. This container is going to bloat. The container is going to bloat. Are you listening to me? What I mean by bloat is that it's going to swell up because pressure is building up inside the container.
Yes.
The pressure that is building up is as a result of the formation of carbon dioxide inside the container. That gas, carbon dioxide, is going to mount a lot of pressure from inside. The container will bloat, but fermentation will continue. Now, if the fermentation reaches 18% concentration of ethanol, the fermentation will stop. And the reason, I need you to write this down. And the reason is because that concentration of ethanol will kill the enzyme in yeast. In fact, it will kill the yeast itself. Zymase is proteinous. It's an enzyme, so it's an organic catalyst. It is proteinous in nature. High concentration of alcohol destroys proteins. High concentration of alcohols destroy proteins. That is why it is not exactly safe for you to drink alcohol because it is damaging protein. We are proteinous in nature. We are proteinous beings. Are we together? So the high concentration of ethanol is going to destroy the yeast. And once it destroys the yeast, once it kills the yeast, fermentation will stop. Are we together? Once it kills the yeast, the fermentation will stop. Now listen to this now. How then can we get dry gin? Dry gin is up to 35-45% ethanol. How do we get dry gin from fermentation process if the fermentation stops at 18% ethanol? Can somebody tell me? Open your mic and speak if you have an idea. How do we convert our 18% ethanol? You started the fermentation and it has stopped. How do we convert that 18% ethanol to 45% dry gin? Anybody? Nobody. Nobody? Okay. Okay, I think I'm getting some charts. Okay. Please, if you send a chart, I won't know you send a chart unless I say send a chart, then I'll go to the chart. Okay, I'm going to keep it open now. Okay. Okay, somebody is asking me to repeat the question. My question is, you perform your fermentation, okay, in this container. I hope my video is still open for you to see me. You perform your fermentation in a container, in a PET bottle like this. And at 18% concentration of ethanol, the fermentation stops. My question now is, how can we increase the concentration of that ethanol from 18% to about 45%, which is the percentage of ethanol in dry gin? How do we make this 18% to become 45%? Okay, I'm going to answer the question. To increase the concentration of ethanol from 18%, you subject the ethanol to, first you are going to filter it. You filter to remove the yeast and insoluble particles in it so that you have your ethanol solution. Then you subject the ethanol to fractional distillation. Fractional distillation. Is somebody following? And you know what fractional distillation is? It's a separation technique that is used to separate mixture of liquids with different boiling points. Mixture of liquids with different boiling points. It's the same as simple distillation, but fractional distillation gives you the opportunity for a more refined separation. More refined separation. So if you use simple distillation, the separation you will get will not be as refined as what you get with fractional distillation. Are we together? So I want us to move real quick because our time is, we are running out of time. So this is suited for to produce dilute, this fermentation is for dilute beverage, okay? Alcoholic beverage, okay? The mixture is distilled to concentrate it, okay? That is one method of preparation. The second method of preparation is by what we call catalytic hydration. Catalytic hydration of ethene. You are adding water to ethene molecule. If you add water to ethene, in the presence of phosphoric acid as catalyst, please pay close attention. I mentioned phosphoric acid as catalyst, but take note that tetraoxosulfate 6 acid can also replace phosphoric acid here as catalyst. So the catalyst can be phosphoric acid. It can also be tetraoxosulfate 6 acid. If you use any of these acids in this reaction, at high pressure, you can see that the pressure will be in the neighborhood of 60 to 70 atmosphere. That's quite high. Okay. Then the temperature will be 300 degrees centigrade. With these conditions, you will convert your ethene and water to ethanol by a process known as hydration. Now, look at the two conditions. If you look at these two conditions, you can tell the advantage of this catalytic hydration as compared to fermentation. The advantage of catalytic hydration is that, number one, it is faster. Number two, it gives purer, industrial grade. You can get up to 99% ethanol using this process. Are we together? So what are the disadvantages there? The disadvantages there is that it is expensive, more expensive to produce. You need a temperature of 300 degrees centigrade. Okay? That means you are going to burn some fuels, or you are going to use electricity. You are going to use some form of energy to generate that temperature. Then secondly, another disadvantage, you need high pressure. Okay? You need high pressure. All right? So these are the disadvantages and advantage. So if you go to fermentation, the advantage of fermentation is the materials are readily available. Sugar, yeast, water, they are all in your house. Come on, let me quickly warn you. I didn't say you should go and start making beer in your house. So don't go and start making ethanol in your house. So you are not permitted to prepare ethanol at home. You are not permitted to do any chemistry practicals at home. Okay, if you are going to perform it when you go back to your respective schools, you can relate with your teachers to set it up for you so that you can do it and see the end result. Don't perform this at home. I have warned you. The advantage here is that the materials are readily available. It is cheap. You don't need high temperature. 30 to 35 degrees centigrade. You don't even need to do much to attain that temperature. All right. Then the disadvantage is that the concentration is low. You have to subject the entire mixture into another system of fractional distillation to get a higher concentration. All right. So I'm going to pause a little bit here. If you have a question, 30 seconds, please ask. 30 seconds. Be fast. Unmute your microphone. Fire your question. Okay. Okay, so I want to assume that everything is clear and everybody understands this. So let's move on quickly. Write a balanced equation for the fermentation of glucose to produce ethanol and state one condition needed. So who can do that for us? Real quick, real quick. Anybody? Anybody? Quick check, quick check, quick check. Unmute yourself. Who wants to try? Who wants to try? Njoku, you want to write it? Okay. Don't worry. When you all buy your stylus, you find this really, you find it very easy. You see? You find it very easy to write. Oh, sorry. That should be... okay. So you should get this. You should get this. Later on, those that want to get one is just 2,500 naira. 2,500 naira. You get one. You roll easily in class. Okay? So C2. Okay? Okay? Okay, that's an extension. I understand. All right. All right. I agree. Very good. Everybody, tada for her. Everybody, everybody. I want to see your own. Everybody's tada right now. Right now. I want to see your own. Everybody. Tada. Very good. Very good. There are some people that are not sending their own. I don't know why. I don't know why. Okay. Very good. Very good. You have done well there. You have done well there. So let us proceed. I want us to finish this. I don't want us to carry it over to another day. This is SS3. So explain why fermentation does not go beyond 18% ethanol. How can dry gin, about 45% ethanol, be obtained from fermentation to glucose? Now, this is the kind of questions you are going to see in WIEC. I need somebody to quickly unmute themselves and answer this. You don't have to write this. Unmute yourself. Okay.
So solution will be subjected to fractional distillation.
Beautiful.
Get higher.
To get higher concentration.
Higher
Okay.
concentration.
Yeah, that the first part of the question says you should explain why the fermentation does not go beyond 18%.
It doesn't go beyond 18% because the ethanol kills the yeast.
Very good. Very good. At concentrations about 18%, the alkanol concentration, the ethanol concentration begins to kill the yeast. Tada for him. Everybody, I'm checking. Tada for him. Real quick. Very good. Very good. Very good. Very good. I like this participation. Good. So let's move on. Chemical reactions of alkanols. Combustion. Real quick. Combustion. Ethanol will burn. We are going to use ethanol as our reference. Ethanol will burn in oxygen to give carbon dioxide and water, and it also produces energy. Okay, in places like Brazil, they use gasohol as fuel for their cars. Gasohol is a mixture. Gasohol is a mixture of ethanol and petrol. In fact, it can be up to 70% ethanol and 30% petrol. Okay? So they use that mixture as a fuel for their cars. I'm not saying you should go and pour such for your car here. It might have issues because those engines they use there are designed to burn that fuel, ethanol, petrol, ethanol mixture. Are we together? Then we say it burns with a clean blue flame and is used as fuel. In fact, there are lamps that are called spirit lamps. So let's move on from there. Reaction with sodium. Alkanols generally, as I'm explaining this, I'm still going to send you the notes. Alkanols, just pay attention. Alkanols generally react with sodium. And when they react with sodium, effervescence will occur. That effervescence is the evolution of hydrogen gas. Evolution of hydrogen gas. Are we together? Now, here we go. We move to WAEC favorite. In fact, not just WAEC, JAMB, and NECO. Oxidation. Please pay close attention here. Alkanols can undergo oxidation depending on the class of alkanol. Primary alkanols can be oxidized in 2 steps. First, they can be oxidized to aldehyde, then further oxidized to carboxylic acid. I repeat, primary alkanols can be oxidized first step to aldehydes. Okay, then further oxidation will lead to the formation of carboxylic acid. Secondary alkanols can only be oxidized to form ketones. Ketones only. They don't form anything else. They don't have 2 steps like the primary alkanols. Primary alkanols is aldehydes first, then carboxylic acid. Ketones, secondary alkanols just form ketones straight up. Okay? Take note of that. Tertiary alkanols do not get oxidized though. They do not get oxidized. But what are these oxidizing agents and how do we know that oxidation has even taken place? If you use oxidizing agent like acidified potassium heptaoxodichromate 6, I hope you all know how to name compounds so that you can move around and be kabashing in chemistry. You'll be speaking in chemistry tongues. You'll be like potassium heptaoxodichromate 6, So that is an orange solution. That is an orange solution. But if you put this orange solution into an alkanol and it turns green, orange to green, then you will know that that alkanol has gotten oxidized. That alkanol has gotten oxidized. All right? Then another one that I didn't state here is acidified potassium tetraoxomanganate 7. Acidified potassium tetraoxomanganate 7. That is acidified KMNO4. Maybe I should write it. Of course, I should write it. I'm talking about KMNO4. Okay, sorry, let me write that N properly before you think it's subscript N. This is small letter N. Potassium tetraoxomanganate 7 acidified KMNO4 is purple in color. This one is purple. If you put it in primary alkanol, it will turn colorless. That means the primary alkanol is oxidized. If you put it in secondary alkanol, it will also turn colorless, showing that the secondary alkanol is oxidized. But if you put it in tertiary, nothing happens to it. It remains purple. That means tertiary alkanol did not get oxidized. So in case you are asked, how do you tell if a set of alkanol is secondary or tertiary? You can tell with acidified KMNO4, okay? The tertiary alkanol is going to resist oxidation, meaning that the KMNO4 is going to remain purple. But this one is not purple. This one is orange in color. This one is orange in color, okay? So this one goes from purple to colorless. while this one goes from orange to green. Purple to colorless, while this one goes from orange to green. All right? I hope this is very clear. I just mentioned an
Then
extra. Sorry?
when it's oxidized is what?
I didn't get you.
When when the K2Cr2 is oxidized, it changes color to what?
To colorless, it forms manganese 2.
No, not that one. The other one.
Which
The
one? This
first
one?
the first oxidizing agent, yes.
Yeah, it forms chromium 3. That's the one that is green. So let me write it here. Manganese 2 is colorless. Chromium 3, sorry, I'm writing manganese again. Chromium 3 is green in color. All right? These are transition metals and they have variable oxidation state. That also we are going to do much later because transition metals is part of the topics you must treat in SS3. All right? So they have variable oxidation state. So its ability to change from orange to green when it changes its oxidation state is the reason why we are using it to test for reducing agents. Okay? I hope this is clear.
Yes.
Okay. So let us clear from here. Then we have explained oxidation. Please remember, we have explained oxidation and we said tertiary alkanols do not get oxidized. You must remember that. Then dehydration. What does dehydration mean? Dehydration means removal of water. Removal of water. Okay? So if you subject this to concentrated H2SO4, if you subject ethanol to concentrated H2SO4, it will give off ethene gas. To give off ethene gas. And what it does actually is to remove hydrogen and oxygen from the ethanol in form of water. All right? And that gives us ethene gas eventually as the product. Then the last one real quick. A lot of things I want us to do. I'll try to see. Yeah, we're going to finish it. We must finish this today. Are we ready? We must finish it. We'll have a little more. I want us to finish it, okay? The last one is esterification. Very, very interesting. Very, very interesting. Esterification is the reaction between alkanols and carboxylic acids. Alkanols, like ethanol, for instance, can react with a carboxylic acid, okay? In the presence of concentrated H2SO4 at a temperature of about 170 degrees centigrade, you will notice a fruity smell. A fruity smell. Are we together? And this is the reaction. This is ethanol reacting with ethanoic acid to form ethyl ethanoate. Ethyl ethanoate. This is a very, very interesting concept, and maybe I should give you an assignment on this. It is very, very interesting. You know, when you go to buy custard and they tell you that this custard is a banana flavored custard, and when you are eating the custard and you are feeling like you are eating banana, there is no banana anywhere in the custard. Are we together? The custard only contains the ester. That's why we call the process esterification. Esterification. It contains the ester that is responsible for the fruity smell of banana. Every fruit has a combination of esters. Every fruit. And that strong banana smell is as a result of this ester. Let me write the name of this ester. Maybe later you go and Google it. Pentyl ethanoate. So if I have pentanol and I react it with ethanoic acid, I put conc H2SO4, few drops, and I heat it to about 70 degrees centigrade. Within less than an hour, the whole place will begin to smell of banana. Very strong banana smell. So your assignment, everybody, write it down real quick. Assignments. Name the esters. By Esther, see the spelling of Esther. Don't go and spell the Esther in your church. Name the esters responsible for the fruity smell in A. Which fruit should I use now? Which fruit? Strawberry. Oh, sorry. Strawberry. Okay. B. Raspberry. Why am I using L? Okay, enough. So, strawberry, raspberry, and C. Any fruit of your choice. Any fruit of your choice. Don't mind my writing. I'm not holding this thing properly. So I hope you understand that. Strawberry, raspberry, and any fruit of your choice. Your assignment. Don't forget that I mentioned that these fruits have a mixture, a combination of esters. And I've told you that these esters are formed by the process of esterification. It is very, very important for you to know. Maybe in our next class, we are going to look at it briefly. It's very important for you to know the name of the alkanol and the name of the carboxylic acid that form an ester. By looking at the structure of an ester, you should be able to tell. By hearing the name of the ester, you should be able to tell. So we are going to do that in our next class so that we can tidy up and close for the day. So you can go and do your exit quiz. I'm going to send you exit quiz. It's going to be powerful. In fact, today's one is going to be CBT. Very interesting. Very interesting there. So it reacts with carboxylic acid to form sweet-smelling ester. In chemistry, you're allowed to use sweet-smelling, even though we don't use sweet to describe smell in English. But in chemistry, sweet is acceptable. You can use pleasant. You can use sweet-smelling. It's acceptable, all right? So, state what happens when ethanol is oxidized with acidified potassium dichromate 6. Name the organic products formed. Unmute your microphone. Unmute your microphone. I want somebody else in SS3, not Njoko and not Okafo. Let me see. Where are my participants? Ada. Okay, no, Ada Ozagu is not in SS3. I want somebody else in SS3. Who now? Okafo, who else is in SS3 that is there?
Fami
Roju likes being silent. In fact, in our next class, you are going to answer all the questions. Fami Roju, Emmanuel, unmute yourself. Yes? State what happens when ethanol is oxidized with acidified potassium dichromate 6 and name the organic products formed.
There is color change.
Huh?
There's color change.
There's color change. But do you know the products formed? Remember I said it is oxidized in 2 steps. What's the first one? What's the second one? Okay, let me tell you what it is. I'm going to go back now and tell you what it is. Okay? Keep your microphone open. Let's go back to oxidation. Now, If we say it's an aldehyde, we mean it's ethanol. Everybody write it. When ethanol is oxidized, it forms ethanol first, then it is further oxidized to ethanoic acid. Famiroju, keep your microphone open because you are going to answer my next question. So when ethanol is oxidized, it will first form ethanol, okay? Then, if the oxidizing agent is strong, it can further get oxidized to ethanoic acid. So, Famiroju, I want you to answer in the same manner. When propanol, propan-1-ol is oxidized, what does it form? Emmanuel.
Sir?
Emmanuel? Okay. Emmanuel is not responding. So who can answer it, please? When propanol gets oxidized, what does it form? Okay, I think Emmanuel is
I'm
back.
here. I'm here.
Yeah, go on.
It forms propanol
And
and
further to what?
propanoic acid.
Very good. It forms
Propanoic acid.
propanol and further to propanoic acid. Tada for him. Tada for Emmanuel. Tada for Emmanuel. Real quick. I want to be seeing it. I want to be seeing it. Good, good, good. More, 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 more. I'm not seeing enough. I'm not seeing enough. The number is rising. Very good. So if it is butanol, it will form butanol, then butanoic acid. Is that clear? So that's for this. So let's quickly look at, let's predict this observation. Okay? Predict this observation. Who can answer this? Predict the observation if a sample of ethanol is subjected to the following test. Sodium metal test. Add a piece of sodium metal to the sample. What will be observed? I want to know those that are paying attention. This is not equation. Observation has to do with your sense organs only. You do your observation with only your senses. That means you don't need to know chemistry to know the observation. Observation is something you can see with your eyes, something you can hear with your ears, something you can feel with your hand, you know, or something you can smell. But we are going to remove taste. You don't come into chemistry and start tasting things up and down unless you intend to quickly meet God. Okay? So, what will be the observation? I need somebody to answer. I've been teaching for a while, and these are, in fact, these are just the chemical properties. What's the observation?
Uncle.
Yeah, Ugoma.
Effervescence
Effervescence, very
occurs.
good. Effervescence, a sound clap for her. That's correct. Effervescence, tada, tada for her. Tada, I'm checking again. Tada for her, real quick, real quick. I am not seeing, oh yeah, oh yeah, oh yeah, tada, tada, good, 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 good. So, effervescence will occur. For those who do not know what effervescence means, it means bubbles. Bubbles will form inside the solution, inside the ethanol solution. Is that clear? So somebody else will give me the second one, esterification test. Warm the ethanol with carboxylic acid in the presence of small amount of concentrated H2SO4. What will be the observation? Emmanuel, you want to say something? Go on.
A sweet fruity smell.
Beautiful, beautiful. A sweet fruity smell will just fill up the space. Very good. You know all those flavors, all those vanilla flavor, all those strawberry flavor, genoa flavor, wing flavor. All those flavors are esters. Okay? They are esters. Very good. Then the next one, oxidation, dichromate test. Quickly, quickly. Somebody else, unmute yourself. Who else is in SS3 there? Quickly. Warm with acidified potassium dichromate. Quickly, somebody. Let's finish up and go and rest. Quickly, somebody. Oh, yeah. What is happening? Yeah, go on.
I think it will change color.
It will change color. Okay, now, as I teach you how to answer questions. If you come to work and you write, it will change color, you are most likely going to get 0. Are you correct? Yes. Did you answer the question? No. So we must learn to answer questions properly. So what is the proper answer? What do you think should be the proper answer?
To change color to green.
To green, you are complete, full score. The solution, the dichromate will change color from orange to green. Very good. If you say it changes to orange, you may not get any score. If you say the color changes from green, you may not get any score. You have to state the color where it is starting from, and the color where it is ending. So that is very, very good. You have all tried. That's very good. Effervescence here, a sweet fruity smell here, and orange color of the solution changes to green since ethanol is a primary alkanol. If it was a tertiary alkanol, there would be no visible change. So quickly, let's look at uses of alkanols. We are looking at the applications now. It's used in perfumes, paints, varnishes, and cosmetics. Okay? Alkanols generally. Ethanol is used as fuel, blended with petrol. I mentioned it earlier, and is also used in spirit lamps. So in those cases, it's used as fuel. Then as beverage, okay, wine, beer, vodka, scotch, all these are alcoholic drinks. Then the next one, antiseptic property. Okay, antiseptic property. Remember, I told you that alcohol attacks proteins. Most of these microorganisms are proteinous in nature. So if you apply ethanol, that's the reason why they put methylated spirit on your injury. Methylated spirit is a blend of about 85% ethanol, 10% water, and 5% methanol. And it is very important for me to mention here, listen attentively. The reason why the ethanol is the ethanol that is the spirit there. That's what is conventionally called spirit. Okay. Now, the reason why it is methylated is to denature it. To denature it means to make it unfit for consumption. Otherwise, people will just go and buy methylated spirit and be drinking. People will just go to pharmacy, collect, and say they want to buy, and they'll drink it as kai. You understand? And that means we'll have a whole community of drunks moving up and down, falling into gutters. Okay? And there'll be crime everywhere. So in order to discourage people from drinking it, they add methanol to it. Listen attentively. Methanol is deliberately added. If you drink methylated spirit, first, the person, not you, God forbid, you will not drink any spirit. If an individual drinks methylated spirit, first, the methanol is going to make the person go blind. Then it will eventually kill the person. So the first thing is to make the person go blind, then eventually death. Take note of this. So take note of this. It will make the person go blind, then eventually kill. Yes.
So pouring it on the injury, won't it not still?
No, you are pouring it outside your body. Okay. There are some medicines. Let me use that word. There are some medicines that are used externally. That means you shouldn't eat them. You shouldn't put them inside your body. What they will do inside your body, is different from what they can do outside your body. Are we together now? You do not want methanol anywhere inside your body. All right. So that is, I hope that answered the question.
Yes.
The damage is from inside your body. It can easily move to your bloodstream, very easily from inside your body than from outside. Okay? Not that it can't, but the amount that your body will be able to absorb from outside is insignificant. Now, industrial feedstock. It is used as a raw material for making so many other compounds like ethers, esters. Okay, that means if you and I decide to establish a company where we'll be making fruit flavors, pineapple flavors. Oh, I should have added pineapple to that list. Pineapple flavor, for instance, we'll need an alkanol. We'll need a certain alkanol. Then get the corresponding carboxylic acid, esterify them, and we are going to get our pineapple flavor. All right. So that is that. Then, as preservative, there are some laboratory materials, especially in biology. There are some, what do we call it? There are some organisms that are preserved inside ethanol. Okay, you can actually preserve rats inside ethanol. You people used to eat rat in biology practical. Sure, you people used to eat rat there. You eat rats and rabbits in biology practical. When they say you should dissect something, then all of a sudden one leg will be missing. Somebody wants to take it home and go and roast. Okay?
Yeah.
So okay, so to preserve some of these small animals, we can put them in a jar of ethanol. It can keep it for so many years. It will preserve it for so many years. Are we together? Because no microorganism will be able to stand that ethanol. The animal you are preserving it with is already dead, so there's nothing else is going to do to it. Okay? But any microorganism that enters there shall die. Are we together? So these are some of the uses of alkanols. So ethanol can be produced industrially by fermentation or by catalytic hydrogenation of ethene. Name each method and state one advantage of one method over the other. Okay, we have discussed that before. Let's move. Let's round up. Let's round up real quick so that we can take your questions and you go and rest. Key takeaways. Very important key takeaways here. General formula of alkanols is CnH2n plus 1 OH, where OH is a functional group. Okay, so if you see a compound that has CH here and there, then OH somewhere, just OH, then you know that is an alkanol. All right, then alkanols can be classified as primary, secondary, or tertiary, depending on how many carbon atoms are bonded to the carbon bearing the functional group, bearing the OH. Now, prepared by fermentation or catalytic hydration of alkenes. You must know the difference between hydration and dehydration. Then hydrogenation. These are different processes, and you must know what they mean so that you do not interchange them. React by combustion, oxidation, dehydration, esterification, and with sodium. You must be able to explain these 5 reactions of alkanols, especially with ethanol specifically. Then confirm by sodium metal esterification and dichromate tests. Confirm ethanol using sodium metal esterification and dichromate test. So this brings us to the end of our class for today. Because our time is fast spent, I'll still give you time to ask your questions. So if you have any questions, so feel free right now to ask the question so that we can proceed from there. Feel free to ask your question. If you want to send it as a chat, please go ahead.